Welcome to this comprehensive guide on test strategies for conventional software. In this video, we'll explore the significance of software testing, the strategies used to ensure quality, and best practices for effective testing. Whether you're a developer, tester, or someone interested in software quality, this video will provide valuable insights. Let's dive in. Software testing is a crucial phase in the development lifecycle. It is the process of evaluating a system or its components to identify defects and ensure that it meets specified requirements. Effective testing enhances software quality, reduces maintenance costs, and improves user satisfaction. Key benefits of software testing: ensures software reliability and performance, identifies defects early in development, reduces maintenance costs, enhances user experience. A test strategy is a high-level document that outlines the approach and scope of software testing. It serves as a guideline to ensure testing is performed efficiently and effectively. The main components of a test strategy include the scope of testing, the objectives of testing, the testing tools and techniques, and the test environment setup. While test strategy and test plan are often used interchangeably, they have distinct purposes. There are several test strategies used in conventional software testing. Let's discuss the most common ones. Black box testing focuses on input and expected output without considering the internal code structure. For instance, imagine testing an e-commerce checkout system without analyzing the back-end code. White box testing requires knowledge of the internal logic of the application. A good example would be testing security algorithms in banking applications. Validation testing ensures the software meets business requirements. This includes both functional and non-functional testing. System testing evaluates the complete system's compliance with requirements. Examples include performance and security testing. To ensure software quality, multiple levels of testing are performed. Unit testing tests individual components or functions, for example, checking login validation logic. Integration testing ensures seamless interaction between modules, for example, testing API calls between the front end and back end. Validation testing confirms that software meets business needs. System testing evaluates the entire application's performance. Debugging is an essential part of the testing process. It helps developers identify and fix defects. Common debugging techniques include code walkthroughs, logging and monitoring, and using automated debugging tools. For effective testing, follow these best practices. Popular testing tools include Selenium for automation testing, Junit and Testang for unit testing, Postman for API testing, Jira for bug tracking, and SonarQube for code quality testing. Software testing comes with its own set of challenges. Common challenges include managing test data and environments, keeping up with fast development cycles, ensuring cross-platform compatibility, and addressing security and performance issues. Solutions to overcome these challenges include using automation frameworks, implementing CI/CD pipelines, regularly updating test cases, and conducting security and load testing. The world of software testing is evolving rapidly. Let's take a look at some future trends. Emerging trends in software testing. AI-driven test automation uses machine learning to enhance test case generation shift. Left testing starts earlier in the development lifecycle, continuous testing in DevOps. Integrating testing in CI/CD pipelines. To sum up, test strategies play a crucial role in software development. Black box, white box, validation, and system testing ensure high-quality software. Debugging and best practices further enhance software stability. As technology advances, AI-driven testing and automation will redefine software quality assurance. Hey everyone, it's Balaji. In today's fast-paced digital world, software reliability is mission-critical. Whether it's an app for work or a game, buggy software is frustrating. So how do we ensure our apps are rock solid? The answer is software testing. We're talking about a systematic approach to squashing bugs and ensuring your software behaves exactly how it's supposed to. Software testing is like putting your code through boot camp. Rigorous exercises, stress tests, and simulations expose weaknesses before they become major headaches. In this video, we're diving deep into software testing strategies that'll turn your apps from buggy messes into polished masterpieces. Alright, let's kick things off with black box testing. Imagine a mysterious black box with buttons and switches. You don't know what's inside, but you interact with it to see what happens. In software, this means testing an application without peeking at its internal code. You feed it data, click buttons, and navigate menus, observing how it responds. Black box testing helps uncover functional bugs that can frustrate users. Think about e-commerce applications. Black box testing ensures that when a customer clicks place order, everything works smoothly. Mastering black box testing is a crucial step in your journey. Welcome back, software warriors. Now let's shed light on white box testing. If black box testing treats software like an enigma, white box testing cracks it open to examine every nook and cranny of the code. We're analyzing code paths, testing conditions, and ensuring every line of code does its job. White box testing is valuable for anyone in software development, not just developers. By understanding the code, we can identify potential security loopholes, logic errors, or inefficient algorithms. It's about being thorough and meticulous in our quest for software perfection. Hold on to your hats, folks. We're diving into validation testing. We've all downloaded clunky, confusing apps. Validation testing ensures your software meets user needs and expectations. It's not just about whether the code works, it's about whether it works well and provides a smooth, intuitive user experience. Validation testing encompasses both functional and non-functional aspects. On the functional side, we check user workflows, business processes, and data integrity. Non-functional aspects include usability, performance, security, and compatibility. Imagine a mobile banking app. Validation testing ensures it's user-friendly, loads quickly, and keeps data secure. It's about delivering a complete package that delights users. Alright, testers, it's time for the grand finale: system testing. This is the epic final showdown where all the pieces come together. We're taking our entire software system, putting it through the ringer, and ensuring it can handle anything. System testing is like assembling a complex jigsaw puzzle. We've tested individual components, now we see how they work together. We unleash the full arsenal of testing techniques: functional, non-functional, performance, security. Think about a complex e-commerce platform like Amazon. System testing ensures everything operates smoothly, even during peak seasons. System testing is the ultimate litmus test for your software before you unleash it upon the world. So there you have it, folks. A crash course in software testing. We've covered black box, white box, validation, and system testing. Testing is not just a chore, it's an investment in the quality and reliability of your software. By embracing these strategies, you're building trust with users and ensuring smooth operation. Remember, building great software is a team effort, and testing is integral. Software, it's everywhere. But is it safe? Have you used an app today? Checked your online bank account? Driven a modern car? Then you've used software. Software is everywhere in our lives. It controls everything from our phones to our traffic lights. But what happens when software goes wrong? Glitches, errors, crashes. These aren't just annoying, they can be expensive, disruptive, even dangerous. Remember that time a software bug caused a rocket launch to fail? Or when a banking app error wiped out people's savings? Not good, right? That's why we need software testing. It's like wearing a helmet when you ride a bike. You hope you won't need it, but you're really glad you have it when things go wrong. Software testing is like being a detective for computer programs. We find clues or bugs before they become big problems. We make sure the software does what it's supposed to do, and we make sure it doesn't do what it's not supposed to do. Think of it like building a house. You wouldn't just build walls and a roof and hope for the best, would you? You'd check the foundation, the plumbing, the electrical. Software testing is the same idea, making sure everything works correctly and safely. Imagine you're launching a brand new online store. You've got amazing products, a slick website, and disaster. The checkout button doesn't work. Customers can't buy anything. This actually happened to a major retailer a few years ago. They lost millions of dollars because of a simple software bug. Their reputation took a hit too. This is why software testing is so important. It's an investment that can save you time, money, and a whole lot of headaches. Section 4. Test strategy, your software's safety net. A test strategy is like a blueprint for testing. It outlines what needs to be tested, how it will be tested, and who will do the testing. It's the master plan to make sure your software is top-notch. Key components of a test strategy include scope, what parts of the software will be tested, approach, what testing methods will be used, resources, who will do the testing and what tools will they use, schedule, when will testing take place, and risks, what are the potential problems and how will they be mitigated. Section 5. Test strategy versus test plan. Know the difference. People often confuse a test strategy with a test plan. They sound similar, but there's a key difference. Think of it like this. Test strategy is the why and how of testing, the big picture stuff. Test plan is the what and when of testing, the detailed instructions. The test strategy guides the creation of the test plan. It's the foundation for all your testing efforts. Section 6. Black boxes and white boxes. Peeking inside software. There are different ways to test software. Two common approaches are black box testing and white box testing. Black box testing is like testing a car without knowing how the engine works. You only focus on the inputs and outputs. Does the car start, steer, and stop? White box testing, on the other hand, is like taking the engine apart and testing each component individually. You need to understand the code to do this type of testing. Both black box and white box testing are important for finding different types of bugs. Hey developers, let's dive into the world of software testing. Whether it's your banking app or favorite e-commerce site, reliability is key. Welcome to Test Strategies for Conventional Software. Today, we'll explore different testing approaches, real-world examples, and industry best practices. So what is a test strategy? It's a high-level document outlining the approach, objectives, and scope of testing. Think of it as your testing blueprint, ensuring comprehensive coverage. Why is testing essential? Imagine a banking app losing your transaction data or an e-commerce site where the checkout fails. Poorly tested software can lead to financial losses, security vulnerabilities, and unhappy users. Testing detects bugs early, ensures reliability, and enhances the user experience. Now let's clear up a common confusion. Test strategy versus test plan. A test strategy focuses on the overall approach and is organization-wide, while a test plan is project-specific, detailing test execution. Let's explore different test strategies. First, black box testing. It tests software without looking at the internal code, focusing on input and output. Next, white box testing. It examines the internal structure of code. Validation testing ensures the software meets user requirements. And finally, system testing evaluates the entire system's compliance with requirements. Consider an online shopping app. Black box testing verifies payment functionality without internal access. White box testing ensures secure transaction handling at the code level. Testing happens in stages. It starts with unit testing of individual components, followed by integration testing to verify module interactions. Then, validation testing ensures functional correctness, and system testing checks the entire system. Debugging is crucial. Techniques include code walkthroughs, logging, and automated tools. Challenges in testing, managing environments, fast-changing cycles, cross-device compatibility, and ensuring security. The future? AI-driven testing. Automated test generation, AI-driven debugging, and self-healing scripts are revolutionizing the industry. To wrap up, test strategies ensure software quality and reliability. A mix of black box, white box, validation, and system testing offers comprehensive coverage, and AI will make testing more efficient and automated.